In this video, we will be graphing the secant function. Remember that secant is the reciprocal of cosine. So we are actually going to graph the cosine function first, very lightly, and that will be a guide that will lead us to the secant function. But first of all, this 2, whenever you have a b value and a potential phase shift, you have to factor out the b value first. So this 2 is going to come outside like this. And then you have to take this 2 and divide, so this will be pi over 2. All of this should be inside of parentheses. There's my secant, and there's my a value, and my equal sign, and my y. Okay, so this is going to be the a value, alright, the amplitude of my cosine function. This is going to be my b value, which is going to affect the period. And this is going to be my h value, which is going to determine the phase shift. Let's start with the period. The normal period for cosine and secant is 2 pi. So to get the new period, you do 2 pi divided by the b value. So that'll be 2 pi divided by 2, which is just pi. So the new period will be pi. We'll do the x-intercepts and asymptotes at the end. The phase shift is right here, but it's going to be the opposite of what it looks like. So it will actually be a negative pi over 2, which is to the left. Okay, so we are graphing the cosine function, and normally when we look at the cosine function, we start right at the y-axis. We start right at an x value of 0 up high. But because we are shifting pi over 2 to the left, I am not going to start at 0. I'm going to start at the phase shift. I'm going to start at negative pi over 2. Okay, so I'm going to use this to be my starting x value. The beginning of the period will be here at negative pi over 2. Okay, so if I count over 4 places, that should be the end of the period. So 1, 2, 3, 4. This should be the end of the period. Now I need all the x values between here and here. So for me, the easiest way to do that is to realize that each one of these marks represents 1/4 of the period. In other words, a quarter period. I don't want to use that color. So I need to figure out what is a quarter period. Well, the whole period for this problem is pi. That means a quarter period will be 1/4 pi, or simply pi over 4. So that means each one of these marks should be increasing by pi over 4. That's why I'm going to add pi over 4. However, I need like denominators. So if I want to add pi over 4, I need this to also have denominator of 4. So to get that, I would multiply numerator and denominator by 2. That will give me negative 2 pi over 4. So this is what I'm going to add pi over 4 to. Think 1 pi over 4. So negative 2 plus 1 is negative 1. So this will be negative 1 pi over 4. If I add 1 and negative 1, I get 0. So this next I'm just going to have 0. If I add pi over 4 again, I'm going to have 1 pi over 4. If I add 1 pi over 4 again, I'm going to have 2 pi over 4. Okay, I put these down here just in case I needed to reduce anything. Most of these don't reduce. This is just negative pi over 4. 0 is just 0. This is positive pi over 4. This is the only one that really reduces, so this is pi over 2. Alright, I can already see where the y-axis will be, so I won't need any additional values. These 5 values will be plenty. Okay, remember, we are graphing the secant function, but our first goal is to lightly graph a dotted cosine function as a guide. So that's what I'm doing. I'm going to go ahead and put the y-axis in here now, mostly so I can show the a value. So the y-axis always goes at 0, and this one has a clear 0 right here, so I'm definitely going to use that. Alright, so there's my y-axis, which is one of my values, so don't get it twisted. This is one of the 5 marks. Sometimes we have to ignore the y-axis because it's not one of the values. This time it's one of the 5. Anyway, the amplitude of the cosine function is 2. So I need to go ahead and mark that off on my y-axis now. So I'm going to go ahead and call this 2 up here, so that's going to make this -2 about here. Alright, now I'm not going to start at the y-axis though. Remember, this there's a phase shift, so my cosine function is going to start over here at the -pi/2 because of the phase shift. Okay, we know that cosine starts off up high, and then it falls to the midline, and then it goes to its lowest point, and then back to the midline, and then its highest point. Alright, so I'm just going to very lightly sketch out the cosine function. Alright, so that's what the cosine function would look like, ever so lightly, because that's not the real thing we're trying to graph here. The real thing we're trying to graph is this secant function. Now, because secant is 1 over cosine, anywhere cosine is 0, it's going to be undefined. You can't divide by 0, so that's going to cause an asymptote. Anywhere cosine is 0. Well, cosine is going to be 0 at these x-intercepts. So that tells me that I'm going to have an asymptote at each of these x-intercepts. So there should be an asymptote here, and there should be an asymptote here. Alright, so I've got those asymptotes. Now I know that the secant function is always the same as the cosine function at the extreme values, the highs and the lows. So these blue points will actually be on the secant function. And then from there you have to approach the asymptotes. So we should be approaching the asymptotes like this. Okay, that is what one period of the secant function looks like. As far as x-intercepts, again, there are none, because the blue graph is really the secant function and it does not touch the x-axis. So that's going to be none. Vertical asymptotes. Yeah, we got those. Notice that the vertical asymptotes happen every half of a period. See how this is only 2 spaces? Every space is a quarter of a period. So these 2 spaces together between asymptotes, that's half of a period. Okay, so I'm just going to pick one of them, and I always pick the first positive one, so pi/4. So I'm going to have a vertical asymptote, which which is always x equals, alright, x equals pi over 4. And then I'm going to add, and again, they occur every half period. So the period is pi, so a half period is pi over 2. Alright, so I'm going to add multiples of pi over 2. Didn't leave myself quite enough space. So I'm going to put n pi over 2. Alright, to capture the multiplicity. Alright, multiples of pi over 2. Multiples of half the period. Alright, and I need to mention that n is an integer. Okay, that is the end of this assignment. So that is going to be the end of this series of videos. I hope these videos have been helpful, and I will see you on the next video.